Here's a graph, a random arbitrary graph that's been transformed, and we are trying to find the new equation of it. The equation is named g, so I'll write g of x is equal to. Now, because the original graph is called f, we need to make sure that f is contained in our solution. So I'll throw an f in there so I don't forget to do it. First shift I like to do is the left or right shift. So for example, I need to find corresponding points that match. This point corresponds with this point on the graph. I could choose to use that one, or this dot to this dot. All of these would work. You find the one that's easiest for you. So for example, and no good reason, I'm going to choose this guy here. 0, 0 corresponds with this dot on the new graph. So, looking at the x value of 0 and this x value of negative 2, I can determine the left or right shift. In this case, this dot has been moved to the left 2. So inside my parentheses, I need to have x plus 2, because all left or right shifts, that symbol there is the opposite of the direction it actually was moved. 2 to the left is x plus 2. The next shift is kind of weird. This is the A shift. This is what stretches it or condenses it, makes it fat and skinny. And to do that, I do a different technique. I like to take a region like this flat section here and this flat section here, for example, and determine its gap. Its gap on the y-axis is 3 units. 3 units wide from there to there. And then determine what that gap is on the new graph. Here's that same top straight section. Here's that same bottom section, which is now 1, 2, 3, 4, 12 wide. The distance from here to here is now 12 units. It was 3 units. So what was the stretch factor? 3 was multiplied by 4 to get this value. Now, the only thing you need to determine is if that 4 is positive or negative. Has this graph been flipped? If it's upside down, then I would make that 4 negative rather than positive. But you'll see that the graph here, headed to the left, is headed down. It's still headed down, so the graph has not been flipped. So we'll leave the positive 4. After you determine the left or right shift and the stretch factor, then we need to apply both of those shifts to one of our coordinate points to help us figure out what the up or down shift is at the conclusion. So I'll go back to my coordinate point 0, 0, which is here. I need to make sure that point ends up here at negative 2, 4. So I apply my left shift too, which would put me here. Now I multiply my y value by 4. 4 times f of x means multiply the y value by 4. Now my y value, after I've moved 2, is 0. So multiplying it by 4 leaves me in this spot. I do not move. My y value remains 0. So what do I need to move this dot up, which is currently here, to get it to here? The answer is 4. Up 4. Now, you should check your work on this problem. For example, go grab another coordinate point. Say that one. We need to make sure this one ends up here. So we can apply our shifts. First, we moved left 2. Now I multiply my y value by 4. My y value where I currently am is negative 2. If I multiply it by 4, I would get negative 8, which is here. Lastly, I said there was an upshift of 4. So this is where I would end if I did all of my shifts for that point. I can check to see if that is the correct location of the end of the final graph here, which it is. 3, negative 4, 3, negative 4. And if your shifts work for multiple coordinate points, then you're going to know it's right, and it's a super way to check. So, I'm going to put up problem number 2. I need you to press pause, work on that problem, and I will show the solution now. Press pause. And there is my solution. I Now let's take a look at problem number 3. Go ahead and press pause now to work on that. And there's the solution to problem number 3.